you know what? So like, please pretend you don't see the solution, the answer down here. Let's talk about like the last bit for 1.1, which is called as 1.114, descriptive and inferential statistics. So what is the difference between these two? Descriptive statistics and inferential statistics. So the easiest way to differentiate between these two is that for descriptive statistics, so what happened is that it's going to talk about a statement with confirmed number. So whatever number that is being mentioned in there, so we have verified that that is actually the correct number for it. But for the case of inferential statistics, what we do is we have values, numbers as well, but those values are an estimate, or what we can do is that we are trying to do conclusion from the statement that we had. Okay, so if it involves confirmed number, so that is going to be a descriptive statistic. So if you're estimating the number or you do conclusion based on the number that you get, so that is called as an inferential statistics. For example, here it says 10,000 parents in Malaysia have chosen Takaful Insurance as their trusted life insurance agency. So this is confirmed. There are actually 10,000 parents out there who actually chosen Takaful Insurance. So therefore, it's called as the descriptive statistic. We know for sure from the data we collected that 10,000 people did that. Okay, so for inferential statistic here, we have the death rate of lung cancer was 10 times higher for smokers compared to non-smokers. So here, this is actually a conclusion. So we conclude that death rate of lung cancer is for smokers, the risk is like 10 times compared to the non-smokers. Right, so this will be the idea. Okay, now we have 4 statements right here, and let's have a look at let's go through this together and decide like which one is going to be inferential and which one is going to be descriptive statistics. Okay, so it says over here the average cost of a wedding is nearly 10,000, so the figure is going to be 10,000. But here, what gives out that this is going to be an inferential statistics is because of the term nearly. So we don't really know for sure that it's going to be 10,000. So it's nearly 10,000. It's an estimated value. So estimated value. So therefore, this is going to be inferential statistics. So I'm going to use notation. Inferential statistic and descriptive statistics. Okay, so that is going to be for number 1. So number 2, in Malaysia, the median salary for men with a bachelor's degree is 30,000 per year, while the median salary for women with a bachelor's degree is 29,000 per year. It is confirmed, so it says over here it's not estimated. It is confirmed it's going to be 30,000 per year for men and 29,000 per year for women. So therefore, this is going to be classified under what do you call it, the descriptive statistics. Okay, so it's a number that is confirmed for sure. So C, globally an estimated of 500,000 children under the age of 15 live with type 1 diabetes. So this word give it away. So the fact that this is going to be inferential statistic. Remember, estimated value, that is going to be inferential statistics. Okay, the last one, a researcher claims that a new drug will reduce the number of heart attacks in men over 70 years of age. So this one is going to be inferential statistic as well, because so this is basically trying to come out with a conclusion. So he did a research and he claims that a new drug will reduce the number of heart attacks in men over 70 years. So it's going to be categorized under inferential statistics. Okay, so that is for inferential and descriptive statistics. Now let's have a look at role of computer in statistics. Okay, the thing is that so the data can sometimes involve a lot of numbers. So if you have 10 data, like 15 data and so on, so it wouldn't be a problem. Like for mean, you can simply use your calculator for that. But for example, in your for your assignment, you should be able to you should at least collect 70 data, I think. Yeah, it should be 35 and 35. So please make sure that you don't have a small population. It should be at least 70 data, or it could be more. Okay, the thing is that as the data gets bigger, so it's not possible for you to use your calculator to calculate the statistics, what I call it, statistic value that you need anymore. The mean, the variance, the standard deviation, and so on. It's going to be a hassle. If you have like, for example, you have 100 data and you're trying to find the mean for that. So like having to key in every single number, that is like kind of ridiculous because you don't know when you might make a mistake, right? So that is not a clever way to do it. So what we do is we're going to use statistical packages, and of course the most accessible software and the most familiar one, the most, what do you call it, the one that we are most familiar with is going to be the Microsoft Excel. So most computers, I guarantee, will have Microsoft Excel. And we also have AMOS, EViews, Minitab, RSS, Smart PLS, SPSS, and S+. So statisticians love SPSS because it can manage very, very big data. But the problem with SPSS is that it is super expensive. Okay, and we also have R as well. So I used to learn R when I was in the University of Auckland. So it is actually a software that is developed at my university. Okay, so that is R, and it's free and it's really, really good at doing the analysis. Minitab, engineers love this. Minitab, I don't know why. I don't know why they would invest money for this. So it is better for you to learn something that is free so that you don't have to invest money on the statistical packages unless the package actually offer you something that is worth it. For SPSS, if you have any problem with any of their packages, you can report to them and they will get back to you. So that's the plus point for paying for them. Okay, so this is going to be how like you do data analysis in Excel. So if you are using your Excel for the first time to do data analysis, that you have to go through this stuff. So you can use this data analysis tool to sketch, graph, and chart. So this is what you're going to do for your assignment later. So you better have this data analysis in your computer or formulas as well. So I think that it is very common for you to use formulas in Excel, like you have this cell plus this cell equal what. So those are in Excel as well. Okay, how do you get the data analysis tools? So these are going to be the way. So first, you're going to click this file over here, and you can have a drop down menu. From the drop down menu at the most bottom, there will be options. Click options, and from the option again, so you're going to come up something like this. So this come after you click option. So you have to choose the add-ins, and after you pick the add-ins, you choose the analysis tool pack, and then click go here. And after you've done that, then only you click OK, and you will come out to this interface, and then you click data and you choose tool pack. No, not yet. So after you click go, something like this will pop up on the screen. You will choose the first one. You pick the first one, which is analysis tool pack, and click OK, and then you will come out and have like your Excel without nothing on it. And then you click the data, and then only this will pop up, and like choose whatever that you wanted, whether you're going to do ANOVA, correlation, covariance, descriptive statistics, and so on. Okay, so you only need to do this for the first time. Yeah, I guess it's only for the first time. Like after that, it's going to come out here right away every single time, or probably not. But you probably, so try to do that. Try to explore that yourself, because I'm not very familiar with Excel, seriously. As a statistician, like Excel is the most basic one, but I am more comfortable with using R and do programming than click on tools like this. Okay, so you're going to be using this for Excel. So try